In this video, we are going to talk about how we calculate arc length of a curve. Here, we are going to use two formulas. If my function is y equal to f of x, then I have to use capital L equal to integral a to b square root of 1 plus dy by dx the whole square into dx. Suppose if my curve is in terms of y, that is x is equal to f of y, then I have to use capital L is equal to integral a to b square root of 1 plus dx by dy the whole squared into dy. The meaning of dy by dx is derivative of y with respect to x. The meaning of dx by dy is the derivative of the function x with respect to the variable y. Let us see the first example. So here is the question. Find the length of the curve y equal to 1 over 3 x to the power 2 plus 2 the whole to the power 3 by 2 from x equal to 0 to x equal to 3. So as I told you before, we need to decide which formula we have to apply. Here the curve is y equal to x, that is the function which is in terms of x, the limit also given in terms of x. So I have to use formula number 1. What is formula number 1? Capital L. L stands for the length of the curve, that is equal to 1 plus dy by dx the whole squared into dx. To solve the problem, I am going to use 3 steps. Step number 1, we are going to calculate dy by dx. That means derivative of y with respect to x. What is y? Y equal to 1 over 3 x to the power 2 plus 2 whole power 3 by 2. So now I am going to find the derivative of this, that is dy by dx. So we have to keep this 1 over 3 as a constant. Then by using the derivative formula, the power 3 by 2 will come front. So we have 3 over 2. Then I have to keep this as it is. Reduce the power by 1, that is 3 by 2 minus 1. That will give you half. Then using chain rule, we have to do the derivative of the inside term. So derivative of x power 2, that will give you 2x. So now I cancel this 3, this 3, this 2 and this 2. So we have remaining with x times x to the power 2 plus 2 the whole power 1 by 2. So this I can write as x square root of x power 2 plus 2. Okay. Now let us move to step number 2. What is step number 2? We need to find 1 plus dy by dx the whole square. So first we have to calculate 1 plus dy by dx the whole square. We have already known dy by dx the whole square. Dy by dx is x times square root of x power 2 plus 2. So let me substitute the value here. So that will give you 1 plus x times square root of x squared plus 2, this all power 2. Okay. So this is equal to 1. Now I have to take square root for this. So this will be 1 plus this term will become x power 2. Then the square root will get cancelled. We have remaining with x power 2 plus 2. So that is equal to, if I expand, so this will give you x power 4 plus 2x power 2 plus 1. So this I can write in the form of a plus b the whole square. So that will give you x power 2 plus 1 the whole square. So that is equal to simply x power 2 plus 1, because I want to write square root of 1 plus dy by dx the whole square. So if I take square root, the square root and square get cancelled. We have left with only x square plus 2. Okay, now move to the last part. What is the last part? We have to substitute these into the formula. So L equal to integral 0 to 3. In place of square root of 1 plus dy by dx the whole squared, I have x to the power 2 plus 1 times dx. So that is equal to integration of x to the power 2 will give you x to the power 3 over 3. Integration of 1 will give you x between 0 to 3. So if I substitute the limits, this will give you 3 to the power 3 upon 3 plus 3 minus the lower limit will give you 0. 3 power 3 divided by 3, that will give you 3 power 2. I can cancel 1, 3 plus 3. 3 power 2 is 9. 9 plus 3 will give you 12. So we will write 12 units as the final answer. Let us discuss one more example. Now see the given curve. The curve is x equal to 2 by 3 times y minus 1 the whole to the power 3 by 2. And we have given the two limits in terms of y equal to 1 and y equal to 9. So we have to change the formula. So now I am going to use formula number 2. So capital L equal to integral a to b 1 plus dx by dy the whole squared. This is y, not x, this is y, times dy. Okay, so step number 1, we have to calculate dx by dy. The meaning of dx by dy is derivative of x with respect to y. So we have x equal to 2 by 3, y minus 1, 3 by 2. So this is what given in the problem, right? Now I have to find the derivative of this. Remember, we are going to do the derivative with respect to y. So keep 2 by 3 as a constant. The power will come front. Then write the remaining term whole to the power n minus 1. So 3 by 2 minus 1 will give you 2. Now cancel 2 and 2, cancel 3 and 3. We have left with y minus 1 the whole power 1 by 2. Or I can say dx by dy is equal to square root of y minus 1. Come to step number 2. In step number 2, I am going to calculate square root of 1 plus dx by dy the whole square. So first let me write 1 plus dx by dy the whole square. So this is equal to 1 plus the derivative of dx by dy is this value, that is square root of y minus 1 the whole square. So this can be written as 1 plus square root and square cancel. We have y minus 1. So this is equal to 1 plus y, 1 minus 1. So 1 minus 1 cancel. We have left with y. But I need 1 plus dx by dy the whole squared. Okay, so I have to take square root of this value. So this will give you square root of y. Step number 3, we have to use the formula. So we know that this is the formula. So let me replace the limits. So here we have 1 to 9 and we have square root of y into dy. So this is nothing but integral 1 to 9 square root of y. I can write 1 by y power 1 by 2 into dy. By using integration, this will become y power 3 by 2 divided by 3 by 2 between 1 and 9. So this 3 by 2 I can change it as 2 by 3. If I substitute the limits, that will give you 9 to the power 3 by 2 minus 1 to the power 3 by 2. So this is equal to 2 by 3. 9 power 3 by 2 can be written as 9 times square root of 9. 1 power 3 by 2 is 1. So that is equal to 2 by 3 9, square root of 9 is 3 minus 1. So that is equal to 2 by 3, 9 times 3, 27, 27 minus 1, 26. And finally, if I multiply 2 and 26, will give you 52 by 3 units. So this is how we calculate length of a curve. The next one, work done by a varying force. Suppose we have a force f of x which along the x-axis starting from x equal to a and x equal to b. Then to calculate the work done by the force, we are going to use the formula w equal to integral a to b capital F of x into dx. Let us see one example. Find the work done by a force f of x equal to 1 over x power 2 n. N is nothing but Newton, the unit for the force, along the x-axis from x equal to 1 meter to x equal to 10 meter. So we know the formula w equal to integral a to b f of x dx. So that is equal to limit 1 to 10. For f of x we have 1 over x power 2 into dx. So this is nothing but 1 over 10. This x power 2 I can take it to the numerator. It will become x to the power minus 2. So integration of x power minus 2 will give you x power minus 1 divided by minus 1 between 1 to 10. This I can say minus 1 over x between the limits 1 to 10. If I substitute upper limit, that will give you 1 by 10 minus of lower limit. So minus, already we have a minus, minus minus plus, replace x by 1, that will give you 1 by 1. So this is nothing but minus 1 plus 10 divided by 10. Minus 1 plus 10 will give you 9 by 10. So 9 by 10 I can write 0.9. Since we are asking for the work, we need to write the final answer as joule. So 0.9 joule. Joule is the unit for work. See you in the next video.